You guys get anywhere? Let's see. What have I told you? I've said don't trust the inequality. Is that what I said? Well, first of all, since it's quadratic, I think the first step is let's move the 6 over. Do you agree? So I'm going to move the 6 over, and then I can keep the inequality like it is. But at some point, now I would try to factor it. You might do the quadratic formula, but I would factor because I think it factors kind of nice. Sometimes you think about 2 and 3 here, but 2 and 3 aren't going to work here. With that negative 6, I need a negative 6 and a positive 1. That's what I need to get that negative 5. So, okay, one more time. If I keep this thing less than, and anyway, then I set these equal to 0 and I get my answers. But if I set them, but I cannot trust the inequality, so I'm not going to write it. I could keep writing the less than symbol, but I just can't trust it. So I'm not going to write a less than symbol. I'm just going to pretend it equals 0, and x plus 1 equals 0. Of course, you move the 1 over, and the answer to this is negative 1 and 6. Right, you guys? Okay, those are my answers. But the truth is, on a number line, this is between negative 1 and 6, and maybe I should test these regions. Now, hang on. I have said a lot of different things today. Did I say something? Let's go back and let's look at the original thing. The original thing was less than. When you move the 6 over, it's still less than. So maybe if it's less than, it's that middle stuff, maybe. I don't know. My teacher sort of said that, but he also said, be careful. Maybe you can't trust your teacher. A few minutes ago, he was calling the x-axis the y-axis, so you got to be careful. Maybe I should just pick a test number, right? What's a good test number between negative 1 and 6?
0.
0. I can take 0 and plug it into the original inequality or this one. They're just one move different. Let's go right here. If I plug the 0 in here, I get negative 6 is less than or equal to 0. That's true. If that's true, my little test point 0 that lived in this region is true, so this is true. So officially, my answer is x less than or equal to the 6, but at the same time greater than or equal to the negative 1. It's my sandwich. It's the numbers in between negative 1 and 6. If I wanted to think visually, watch this, a little more visually. This is a parabola. When I draw this little number line, this is basically the x-axis right here. It's the x-axis. We found where it equals 0. We found negative 1 and 6 where it equals 0. This is a parabola. I found its x-intercepts. Listen, is it upside down or is it right side up? It's right side up. Now, I don't really care about all the details, but it's a parabola that's right side up. So again, when is it less than 0? When is it hanging below 0? When is it hanging below the x-axis? And that's when it's between negative 1 and 6. So what am I doing? I'm teaching you how to do these problems 2, 3, 4 ways. Good luck deciphering all that. Here's one more. Again, totally visually. This time you don't have any equations. Look at this. Just a visual picture like this. Here's a function called f of x. Here's a function called g of x. And the question is, let's see, what's the question? All right, the question is, okay, hang on, there's a function called f, there's a function called g, and the question is, when is f of x greater than or equal to g of x? So, when is f bigger than g, right? I mean, this is not too hard. When is f bigger than g? Or when is f, on top of g, right? Bigger than g. When are the when is these y values bigger than these y values? Or when is f above g? There's a lot of ways, and so you can just look at this picture. I think you can tell me. When is f above g? When you're way over here, it looks like g is above f. But starting about right here, it looks like f is above g. Do you agree? So f is above g, f is above g, f is above g, f is above g, all the way to here. So that would be what values?
Negative 3 to 6.
I think so. I think from negative 3 to 6. I don't think the 5 and the 7 and the negative 2 and the 4 have anything to do with anything. I think it's between the negative 3 and the 6 is when f is above g. When is f above g? I think when x is between, I can just visually see it, but when x is bigger than the negative 3, but less than the 6, or equal to the 6. You guys okay? By the way, what if this didn't have an equal to? What if it just wanted, when is f greater than g? Well, then it doesn't want the places where it equals. So what do? How does my answer change?
It's the same numbers, you just have...
Yes, good. It's the same places, but I just don't want it to equal, so I don't want it to equal the negative 3. I want it to be really between the negative 3 and 6, and not equal. All right, well, so I just spent some time pushing ahead to kind of finish the ideas of this chapter. So next Tuesday when we come to class, I can answer all kinds of questions because I don't really need to teach you a bunch of new stuff. There might be some word problems. There might be some stuff in chapter 4 you need help with. So Tuesday's a good day for that. And the test is next Thursday. One more thing. Today we have a quiz, and today's quiz is mostly about 4-1. And I thought I might just remind you of if I gave you a function like this, could you describe the shifts and know how to graph it? That's what today's quiz is. Knowing how to graph it, describing the basic shifts. So I just thought I'd do one example before I gave you the quiz. So first of all, let's see. What would you say? I'll tell you what, first of all, of my 6 basic functions, which one is he? What do I have? I got the squared guy, the square root guy, I got the cubed guy, the cube root guy, I got the absolute value, and I got that other weird one. Which one is he? He's the cubed one. And the cubed one, just if you don't mind, has this basic shape. So you were supposed to sort of memorize that. You're just supposed to know these 5 or 6 basic functions. So he's one of them. Anyway, we know which function he is. Now talk to me about him. What's the plus 4 doing out here?
That means that you shift up.
Up 4, right. Now, on today's quiz, I asked you for some, I think I say, describe the shifts or transformations. So I asked you to write down some words. So please do, like I do. Up 4, anything else you want to say? What about to the right 2? She says to the right 2. She's right, right? To the right 2. Okay, all right. Up 4, right 2. All right, I got you. Anything else?
Flips it upside down.
That negative sign flips it upside down. And then this last thing is not all that, this last thing is just a little hard to graph, but what the fact that it's multiplied by a 3. I mean, part of the reason I put that 3 in there is to help you realize it's not a shift. The 2 is a shift to the right. The 4 is a shift down, up. And the negative sign flips it upside down, and the 3 is not a shift anywhere, but it is a stretch, right? So it's stretched by a factor of 3. And that's the way they say it, stretched by a factor of 3. I don't know if you need to mention that, but when you draw your picture, it makes it a little bit narrow or skinny because it's stretched. Anyway, let's try to draw this thing. What am I doing? What the hell am I doing? I'm taking this shape, which kind of normally lives here, and I'm moving it up 4, to the right 2, well, that ain't bad, and then just draw it. Wait a minute, something I forgot. I don't want to draw it. I want to draw it upside down, which means this side flips up, this side flips down. So here it is. Here it is. You guys okay with that? And did I draw them kind of skinny or narrow? I don't know. Good enough for me. I'm grading it. I did good enough for me. You guys okay? A cubic function, know the basic shape, know how to move it over to the right 2, up 4, and flip it upside down. Yeah. Label it a little bit like that so I can tell what you know what you're doing. Put down some little descriptions here so I know what you're doing. Yeah, good job. What time is it? What is it?
8:45. Yeah.
The clock's broken. 8:45?
9.
Okay, all right. Well, let's stop and let's do our little quiz.